Acids are an integral part of chemical assay. They are used to dissolve sample material into ions in solutions. Decomposition is one of the first steps to be accomplished in sample preparation. Therefore, in this presentation, I will be presenting the most commonly used acids in chemical analysis. I'm Rob Boyko, Boyko Mineral Exploration, and welcome back. Hydrochloric acid is usually purchased with a concentration of 37% weight to weight. This equates to 11 to 12 normal or molar, that is 11 to 12 moles per liter. It is also labeled as muriatic acid. As shown, the chemical formula is HCl. It is listed as a strong acid, which dissociates in water to form a chloride solution. It has the ability to form strong complexes during reactions with gold-3, titanium-3, and mercury-2 elements. In a concentrated form of 37% weight to weight, it will complex with ferric iron, gallium-3, indium-3, and tin-4. Arsenic, antimony, mercury, germanium, tin, and selenium are easily volatilized. However, the mercury, tin, and rhodium will volatilize at later stages during the evaporation process. This could result in some loss of analyte. Caution must be taken. Adding manganese dioxide, permanganate, and/or persulfate to hydrochloric acid will result in a toxic chlorine gas. Hydrochloric acid is more effective when heated. It will dissolve carbonate rock, natural oxides, most hydroxides, borates, sulfides, as well as cement. In some instances, this acid is stored in a blue color coated container. In regards to hydrochloric acid, there are elements and compounds that this acid will not dissolve. Most silicates or ignited oxides of aluminum, beryllium, chromium, iron, titanium, zirconium, and thorium will not be affected. Other oxides such as tin, antimony, niobium, and tantalum will not dissolve. There are others such as zirconium phosphate and sulfates of strontium, barium, radium, and lead. These will not be attacked. It has no effect on alkaline earth fluorides or the mercury sulfides, or material containing niobium, tantalum, uranium, and thorium will also not be affected. Caution: this is a very strong acid. It will cause burns. Always use proper protective equipment when handling this acid. Nitric acid is usually purchased in concentrations of 70% weight to weight. It is available in higher concentrations in the 95 to 98% range, commonly referred to as fuming nitric acid. The concentration at 70% equates to 15 to 16 normal or molar, which is 15 to 16 moles per liter. This acid has a specific gravity of 1.42 grams per milliliter. Its chemical formula is HNO3. This acid is listed as a strong acid. It is also a strong oxidizing reagent. As it dissociates in solution, it forms a nitrate solution. Elements within this solution during reaction will form a nitrate compound. This acid will boil away quickly before a sample is fully oxidized, that is to say, decomposed. Therefore, this acid is normally used in conjunction with another reagent, such as hydrochloric acid. It is normally used to dissolve metal sulfides, arsenides, sulfoarsenides, tellurides, selenides, as well as phosphates and tungstates. It is also used for the parting of gold as a process in fire assay. The downside is that it will not attack gold, hafnium, tantalum, zirconium, or the platinum group metals, with the exception of palladium. Others will be slightly dissolved. During reaction, the aluminum, boron, chromium, gallium, indium, niobium, thorium, titanium, calcium, magnesium, and iron, an insoluble oxide layer will actually form, thereby freezing the reaction, and dissolvement is hindered. However, magnesium, calcium, and iron will dissolve in a diluted solution of nitric acid. Combining tungsten with nitric acid results in the formation of tungstic acid. A metastanic acid will result by combining tin with nitric acid. However, gold and platinum will not dissolve, as these metals are referred to as noble metals. That is, they resist any chemical reaction. This acid is used as an oxidizer for the removal of organic material. This is usually followed with perchloric acid treatment. Now, nitric acid is also used to convert sulfides into sulfates or precipitate free sulfur. This acid at times is stored in a red color coated container. In most cases, this acid is used to dissolve samples for instrumentation analysis. It is best suited for intercoupled plasma mass spectroscopy. Word of caution. This strong acid is also a strong oxidizing reagent. Besides a painful burn, it will turn your skin yellow in seconds. Use PPE when handling this and any other acid. Aqua regia, sometimes referred to as royal water, is also a strong oxidizer. This is due in part as the acid is a combination of two acids. It is a mixture of 1 part concentrated nitric acid and 3 parts of concentrated hydrochloric acid. When these two acids are combined, chlorine and nitrosyl chloride gases will evolve. Aqua regia makes a good solvent for the decomposition of gold in the platinum group metals. However, silicates are partially decomposed. Metals are kept in solution as chloride complexes. This is due to the low pH of the solution, that is, in other words, the solution's acidity. This acid solution is typically used to dissolve base metals, such as copper, zinc, lead, iron, and manganese. It is also a good solvent for pyrite, sphalerite, arsenide, selenide, cinnabar, molybdenite, and wolframite, all of which are sulfides. The downside is that it has little effect on rhodium, iridium, and ruthenium. It will not dissolve titanium, but it will volatilize osmium, which will result in the loss of osmium analyte. As an important notation, if lead is present, to prevent the formation of lead sulfate, the hydrochloric acid is added first until all of the dihydrogen sulfide is expelled. Then the 1 part of nitric acid is added to the solution. Sulfuric acid is commonly purchased as a highly concentrated solution, typically 96% weight to weight. This equates to a concentration of 36 normal or 18 molar, which is 18 moles per liter. The chemical formula is H2SO4. It has a specific gravity of 1.84 grams per milliliter. Its boiling point is 360 degrees centigrade. It is commonly diluted to a 1-to-1 ratio. Being a powerful dehydrating reagent, it will remove hydroxides and hydrogen to form water from organic material. It causes a black charring of organics, which is not easily removed by wet ashing processes. Due to its high boiling point, some analyte may be lost due to volatilization. Iodine can be distilled quantitatively. Mercury, boron, selenium, osmium, ruthenium, and rhodium will also be lost due to volatilization. Reactions are limited on insoluble sulfates. When heated, sulfuric acid acts as an acid and an oxidizer. Sulfates are converted to sulfites. Sulfuric acid is also used to expel hydrochloric acid, hydrofluoric acid, and nitric acid by evaporating to fumes. Mixed with hydrofluoric acid, it becomes a common solvent for the determination of ferrous iron. When mixed with hydrochloric acid, it has the ability to dissolve basic iron and aluminum phosphates. Sulfuric acid does attack aluminum and titanium oxides. It is sometimes stored in a yellow-colored coated storage container. Word of warning, use your PPE. Perchloric acid is one of the most dangerous acids available when it is in its concentrated form. It is usually purchased with a concentration of 12 normal or molar, that is 12 moles per liter, which is 72% weight to weight. It has a specific gravity of 1.67 and a boiling point of 200 degrees centigrade. The chemical formula is HClO4. It is not only a powerful oxidizer, it is a powerful dehydrating agent. At 160 degrees centigrade, it becomes an oxidizer. However, in diluted form, it is not oxidizing. This acid will not attack gold or the platinum group metals. However, in its concentrated form, it will oxidize other metallic elements to their highest oxidation states. Lead and manganese will only be oxidized to their 2+ oxidation state. All perchlorates are soluble. The exception is potassium, rubidium, and cesium. It will precipitate antimonic and tungstic acids. It is also used to dissolve sulfides and sulfates. To remove silicates, perchloric acid is used in conjunction with hydrofluoric acid as well as for the analysis of silica content. The silicates are dehydrated by the perchloric acid, then removed by the use of hydrofluoric acid. For the analysis of silt and soil samples, it is mixed with nitric acid at ratios of 1:3 or 1:4 for the sample dissolution. I did say that perchloric acid is dangerous. In its concentrated form, it is an extremely powerful oxidizer. This acid is used for the production of rocket fuel as well as explosives. Never allow this acid to dry out. The crystal residue is extremely shock sensitive and unstable, similar to nitroglycerin. It is known to violently explode. These salts can form during long-term storage or if the solution becomes contaminated. Always inspect carefully before removing the cap. If crystals are suspected or the solution shows crystallization of any type, treat it as an explosive and discard appropriately according to your local laws and regulations. The following videos will show how dangerous this acid can be. The last video is of the destruction of a container of perchloric acid found in a soccer field.
der havde vi sådan en flaske stående nede på værkstedet, som vi gik sådan og skulpevendte en gang imellem. Og så hvis du fik et brændsår, så smurte vi det på brændsår. Så den der meget spidse smerte, ikke? Og nu har jeg lige været inde og læse om det. Det er jo allergifremkaldende.
Hold da kæft! Er du?
When working with perchloric acids, always use a fume hood that incorporates a washdown facility. Perchloric acid is an excellent solvent for stainless steel. It oxidizes the chromium and vanadium in the steel to hexavalent and pentavalent acids. Fume hoods designed to be used with perchloric acids contain higher concentrations of molybdenum and are equipped with a washdown system. In concentrated form, perchloric acid reacts violently with organics. Vapors should never be allowed to come into contact with organic material, such as rubber stoppers. Vapors can condense to form those dangerous crystals, which are highly shock sensitive. These salts, also known as perchloric acid crystals, can violently react from a vibration of a fume hood. It is therefore a good practice to wash down the hood after every use. Never allow these crystals to accumulate. All spills and splashes must be immediately diluted with copious amounts of water, then mopped up with woolen cloths. Never cotton material. Because perchloric acid is so dangerous, I have to add the do not do it. That is, never mix this acid with a strong reducing agent. This acid is used to make rocket fuel. More specific, it is used to produce ammonium perchlorate, which is a major component in rocket fuel production. It is also used to aid in the production of explosives. Okay, never use a hot plate when working with bismuth metals or alloys, especially when working with this acid in a concentrated form, or dissolve metals in the presence of heated hydrogen gas. Never use heat when dissolving powdered aluminum, silicon, or antimony 3 compounds, and never mix perchloric acid with hydrazine, hydroxylamine, or hypophosphates. This is not forgiving. Due to its nature to react violently with organics, never mix with oils, fats, greases, or wax, and definitely never mix with another dehydrating agent. Never apply heat when adding to cellulose, sugar, or alcohol. Never evaporate alcoholic filtrates after collecting potassium perchlorate precipitate. Now this last snippet is a reminder. Remember it well. Hydrofluoric acid is another very dangerous acid that is quite commonly used. It is normally purchased with a concentration of 29 normal or molar, which equates to 49% weight to weight. It has a specific gravity of 1.19. It is never stored in glass containers. Always store this acid in polyethylene bottles as it will eat through glass. It is an acid that is used after the addition of hydrosulfuric or perchlorate acids. It is used to form soluble salts and to remove fluoride ions and silica compounds. Any dissolution is done using platinum containers. Teflon can be used if the temperature is below 250 degrees centigrade. Above this temperature, it will attack the Teflon. A 1-to-1 ratio with concentrated sulfuric acid is used to dissolve refractory materials such as tourmaline, garnet, magnetite, ilmenite, chromite, corundum, and others. This process is used for the analysis of ferrous iron, which is iron 2, as well as the alkalis. As mentioned earlier, hydrofluoric acid can be used to remove unwanted silica, as well as for the quantitative analysis of silica. Adding this acid creates fluorosilicic acid and water. Applying heat to the solution transforms this fluoride acid into silicon tetrafluoride gas, which is driven off, leaving the residual as hydrofluoric acid. Now samples must be ground to fine powder and wetted with distilled water. By doing so, avoids any dust or spray resulting from the application of the acid. This prevents any loss of analyte. The solution is heated in a sand or water bath to about 80 degrees centigrade for about 1 to 2 hours. This removes the silicates. This also avoids any colloids from forming, which in turn stabilizes the solution. It also inhibits the formation of hydrolytic compounds. The remaining fluorides, if still present, is then removed by evaporation with sulfuric, nitric, or chloric acids. Using boric acid and sodium tetraborate will convert the fluorides into boron, tetrafluoride, which is also volatile. In turn, can be driven off by evaporation. As stated earlier, hydrofluoric acid is very dangerous and must be handled with care. Proper personal protective equipment must be used. This acid is extremely corrosive. It is also known to produce deadly hydrogen fluoride gas during reactions. If area is not ventilated, do not use it. Preferred method is a fume hood. Due to its corrosive characteristic, any contact with skin will be extremely painful. If the acid is cold, white spots will quickly appear. However, if hot, yellow ulcerous sores will appear. If emergency medical treatment is not adhered to, this acid will penetrate into the upper soft tissue, which will cause tissue necrosis. This is when the blood to the affected area is restricted, causing death to the surrounding tissue. If not acted upon quickly, it will quickly penetrate deeper into the soft tissue and has been recorded in some cases to penetrate right down into bone. Upon contact, the affected area must be immediately flushed with cold water. Then an anti-gel is applied. It is then followed up with medical treatment and assessment by a medical doctor or specialist. Always keep a tube of calcium gluconate in the first aid kit for such emergency response for any hydrofluoric acid incidents, no matter how small or minor. Orthophosphoric acid, commonly referred to simply as phosphoric acid or phosphoric 5-acid, is a mineral inorganic acid. Orthophosphoric acid refers to phosphoric acid in which the prefix ortho is used to distinguish the acid from related phosphoric acids, called polyphosphoric acids. Ortho acids with concentrations less than 95% weight to weight will contain 68% diphosphorus pentoxide. Now, phosphoric acids that have diphosphorus pentoxide concentrations greater than 68% are termed polyphosphoric. Now, polyphosphoric acids are highly condensed. Their complexities are far beyond the scope of this presentation or series and will not be discussed. Now, phosphoric acid is usually purchased having a concentration of 45 normal or 15 molar, that is 15 moles per liter. Now, this equates to 85% weight to weight. It has a specific gravity of 1.68 and a boiling point of 158 degrees centigrade. Chemical formula is H3PO4. Any reaction with this acid produces phosphates and complex phosphates. Caution: this acid will dissolve glass at 300 degrees centigrade. It can dissolve oxides, but is rarely used due to its high boiling point and low volatility. It has the ability to dissolve alumina, chromium ores, iron oxide ores, and some slags. A mixture of phosphoric acid and sodium pyrophosphate will dissolve biotite, garnet, olefine, etc. A mixture of sulfuric acid easily dissolves alumina and chromium ores and alloys. Warning: upon contact with skin, burns can be very serious. Recovery from serious burns can be very lengthy. Upon contact, immediately flush with copious amounts of water or saline solution and seek medical assessment. Acetic acid is a carbon-based organic acid. It can be purchased as a solution or as crystals, solid crystals that are dissolved to create an acidic solution. Solution concentrations up to 99.7% weight to weight may be purchased. The crystal form is better or equal to 5-9 pure. The chemical formula is CH3COOH. Notice if the formula contains a carbon atom, it usually signifies that it is an organic acid. Any hydrogen atom in front of the formula signifies that the compound is a non-carbon-based acid. An example would be HCl for hydrochloric acid or HNO3 for nitric acid. The solubility in crystal form is 100,000 milligrams per liter at 25 degrees centigrade. In solution, it has a density of 1.045 at 25 degrees centigrade, with a boiling point of 117.9 degrees centigrade. Now this is a weak acid, normally used to dissolve carbonates and phosphates. It is also used as a neutralizing agent. Oxalic acid is also a weak acid that is commonly used. It too comes in crystal form or in solution. Solutions may be purchased with concentrations up to 99% weight to weight. Now in crystal form, the ACS grade is very pure. Its chemical formula is COOH2. Notice the brackets. This signifies that it is a diatomic molecule, which means that it is two molecules joined together to form the ion in solution. The specific gravity is 1.653 and its boiling point is 149 degrees centigrade. This acid is used to selectively dissolve analyte in ores and concentrates, both for qualitative and quantitative analysis. Tartaric acid is another weak acid that is commonly used in chemical assay. A typical concentration is 10% weight to weight. It has a chemical formula of C4H6O6. In crystal form, it is typically 99.5% pure. It has a density of 1.78 grams per milliliter and a boiling point of 275 degrees centigrade. Solubility is 139 grams per 100 mils at 20 degrees centigrade. This acid is used to avoid or suppress any metal hydrolysis that may occur during a chemical reaction. The acids that we talked about in regards to general chemistry usually referred to inorganic acids such as hydrochloric acid, sulfuric acid, hydrofluoric acid, etc. Now if the acid contains a carbon component, that is a carbon atom, it generally is classified as an organic acid, meaning that it is carbon-based. In this presentation, I listed 3 common organic acids used in classical assay, and of course there are more. The study of organic acids will not be introduced due to its complexity. This slide is just to inform that there are other acids that may be used in classical analysis. In this presentation, I introduced you to the common acids that are used in classical chemical assay. There are other important points in regards to dissolution of a sample that must be taken into consideration. Therefore, in the next presentation, I will be discussing some of those points regarding the decomposition of your samples. I am Rob Boyko, Boyko Mineral Exploration. I hope that you will view the next segment of this series, and if you liked this presentation or know of someone who may benefit from this series, please give it a like and a share. It's my only reward. Thank you for watching.